Hello and welcome back to the CCNA journey with me, Ryan, and in this section we're going to continue with VTP, the VLAN trunking protocol. In this video we jump into the command line and have a look at how VTP actually works, and I make a few mistakes along the way, but I've kept those mistakes in the video so we can use it as a troubleshooting method. For those who don't know, you can contact me here on YouTube, on Facebook, LinkedIn or Twitter. So here we are in Packet Tracer. We have 3 switches, no configuration between them, and the switches have been connected using a crossover cable. So first things first, what we're going to do is have a look at the default configuration of VTP. And as I said many times before, the way we do that is using the kind of main show command for VTP, which is show VTP status. Show VTP status is kind of the only show command you're really going to be using at the CCNA level, and it kind of gives us the information we need. It tells us the default VTP version, so version 2. It tells us the revision number. So remember when I said in the previous video, every time we make a change to the VLANs, like adding, deleting, or anything like that, it actually increments the revision number, and the highest revision number indicates the most recent up-to-date database. It tells us how many VLANs are actually supported and how many actually exist. So 5, obviously we've got those default VLANs we can't delete, and maximum VLAN supported locally. You'll find with some switches that even though we have obviously 4,000 plus VLANs to be able to be configured, not all devices support that many VLANs. So it's something you want to look out for when you're out in the field and speccing up switches and routers. Make sure that it actually supports the right number of VLANs that you need. And it also shows us here, one of the most kind of important things really is the VTP mode. So we said in the last video, there are 3 modes: server, client, transparent. We said server is the default, and rightly so. It looks like it is the default, and server means that we can create and delete VLANs, and those VLANs are then, or those changes are then propagated to other switches. And we talked very briefly, I believe, about VTP domain. Now at the moment there's nothing there, which means that it's actually null. So null will be nothing. Now when we create something here, it will ensure that people inside the VTP domain receive and action those updates. In Packet Tracer, when you update the VTP domain name on this switch here, it will send out the VTP updates, but the switches downstream, even though they're configured with null, it will not use the domain that you've configured. So what do I mean by that? Well, in most situations, most switches, from at least my experience, is that if I have 3 real switches, so physical switches, set up in this sort of topology, and I change the VTP name to, let's say, the word test, but these downstream switches are set with null, i.e. they have nothing in the VTP domain name, then the normal behavior is to actually accept test and become part of that VTP domain. In Packet Tracer, that doesn't happen. You have to go to the switches and update the VTP domain name, and that goes back to a few reasons. One, it's because it's a simulation of a switching environment, and Cisco's obviously done their best to try and replicate that, and there are some minor differences or certain commands that don't quite work as you would expect. And 2, sometimes with VTP, especially in the older generation switches, some of the configuration is switch depending. What I mean by that is one switch has one default config, another switch has another default config. But as far as I can tell from my experience with VTP, most switches, if they're not set with a VTP domain name and you create a VTP domain name, other switches will inherit that VTP domain name once it receives some VTP packets or VTP frames. Pruning. Pruning we'll speak to in a bit later. And then a few other things down here. The only kind of real important thing to talk about is this Md5 Digest. This Md5 Digest here is like a hash, and this hash is used to ensure that the databases are all in sync. So VTP status is very detailed, gives us everything we need to know, at least at the CCNA level, and allows us to start configuring. So what we'll do here is we'll set up a VTP domain name on this switch, and then we'll check whether it propagates out and what happens with the revision number. So to do that, we obviously go into config terminal, we type in VTP domain, give it a name, and you can see here it says it's gone from null to test. And we can see now the VTP domain name is test. If we go to a downstream switch, we can see that it did not participate or did not accept that VTP domain name. Now maybe that's because we haven't made any changes. So let's go back and increment the revision and see if I'm wrong here. So let's create Vlan 10. So we've created Vlan 10, no ports are in it. Let's go down here. Vlan 10 does not exist. So let's go and put it in the test VTP domain. It's worth knowing that the VTP domain name is case sensitive. Now let's have a look what we got here. So the switch on the left is the one that I originally changed to test, and then the switch on the right is the one that I changed later. Notice that the existing VLANs on the left is 6, whereas the one on the right is 5, and we can see that revision number here is incremented to 2 versus 1 over here. So that tells us that actually what we would expect to see is this digest is actually not the same, therefore these devices are out of sync. That's not always obvious, but in this case it is, because we can see it's kind of the VLAN numbers are different and so forth. So again, what normally would happen is VTP will send out updates every now and then, but VTP is inherently slow, so we can push out another change, and now it's part of the domain name. The switch on the right will actually see those changes. So again, we can see by refreshing that it's not aware of anything. If we go onto this switch, let's create Vlan 20, name it test 1, end, and now let's go back. Now that is completely wrong. I was expecting that to update. Let's do let's change it to client, and let's create another VLAN. Okay, so we're not seeing any VTP traffic there. Is that because... Okay, so good little troubleshooting here. VTP only runs over trunk ports, and the switches have no trunk ports. That's probably because we know from our previous lessons that DTP, the dynamic trunking protocol, is used by default to create trunks between switches. So if we have a look at the ports between these switches, which is Fast Ethernet 01 and 02, so we can see there's no commands underneath the interface, which means it's running the default, but we don't know what the default is. Using the switch port command, we can see that it's dynamic auto. We know from our DTP conversations previously that 2 switches running dynamic auto will not form a trunk. So what we're going to need to do is actually set one of these switches to dynamic desirable, or manually set it to a trunk, because when they're both setting as auto, they're both passive, and DTP does not form a trunk. So let's just go ahead and make one of these guys the person in charge to bring up that trunk, and let's do the switch down here. So now we've got a trunk, and we start to see the existing VLANs pop over. Okay, so that is client, that is server. What we're going to do now is switch over to this guy. Now you might be wondering, why is this happening? Why is this gone orange? That's because spanning tree is now coming up and checking that there's no layer 2 loops, and we'll come to spanning tree a little later. So let's go now to this top switch. So just to kind of explain where we are so none of us gets lost. This switch is originally a server switch, and it's set up with test as the VTP domain. We set up a trunk between these two devices by setting this port down here as dynamic desirable. And then when that trunk was formed, we saw that the VTP information came down to the switch. My comment previously about the VTP domain not being accepted by these switches, let's see if that's wrong. Let's go on to this switch now. Let's configure it as a trunk port so it should participate in VTP. But if we do the show VTP status, we don't have a domain. So let's set this as a trunk and see whether it brings up a domain on its own or not. So it's got a trunk port now. And I was wrong. So these switches do behave as I would expect. They do accept the VTP traffic, and when they're configured with null, they accept the domain name that they actually receive because they're set to null, and then they inherit that domain name and become part of the test domain. Great. We can also leave this guy as server. So we've got a server and a client, and then obviously, as we know, on servers we can create those VLANs, and on clients we cannot create those VLANs. So here on a server, let's go ahead and create that VLAN and see what the impact is on the upstream switch. So I'm down here at the moment. So let's go into VLAN 50, name, test, and then the VTP status. As we know, it increments by 1 every time it's, the revision number increments by 1, and now we have 9 VLANs. Let's go up to this person, and this person was the original VTP server, and we can see that it also incremented its VLAN to 9 and its revision number to 7. So if I do show VLAN brief, we should be able to see VLAN 50, the one I created down here. And if we go to the switch, which is our client, we can also see that that VTP message went up to the top switch, and the top switch passed it through to the bottom switch. We know that this guy is now a client, so should we be able to create VLAN changes on this person? Let's have a look. Let's do VLAN 100. It says here you go. VTP configuration is not allowed when the device is in client mode. So what we can do, change it to server, and then we can make that change. And again, the existing number of VLANs has gone to 10, the revision number has gone to 9. That message would go up to this switch, go down to this switch, and if we check on this person, we can see that it's actually gone up to 10 and revision is now 9. So a few things we learned there. First of all, we know that the servers are able to update the VLAN database and propagate that to everyone else. Clients are not. We knew that from our slides, but it was always good to confirm. We know that VTP requires a trunk, and if a trunk port is not configured between the switches, VTP messages are not sent, and we saw that at first hand, something that I actually overlooked. And then we also saw that the VTP name, if it's left as null 0, or sorry, not null 0, just null, it's left a null, when it receives the VTP packet with a name actually put inside that, it accepts that VTP and becomes part of the domain. So you now might be asking, well, what if it's already part of a domain and we change the domain? So it's gone from test to test1. And if we go downstream, still part of test. So only when it's not configured with a VTP domain name does it actually update its own VTP domain name from the messages it's received from other switches. Once it's set up, it will no longer accept different domain, so you have to go around and make those changes manually. Now another thing that's just popped up on the screen that's worth talking about is because we're using DTP, the Dynamic Trunking Protocol, it's actually able to identify that there's a VTP domain mismatch, and it's teared down that trunk between us. So that does mean that if the trunk was set up as static, this wouldn't happen, but because we're using DTP to help formulate those trunks, it's also able to identify the VTP domain name, and also is able to sort of raise that as a concern for us, and for us to actually fix that, because you wouldn't really want multiple VTP domains across a layer 2 network. You'd want them all to be synced, because of course in most instances you want your VLANs everywhere. Now, as I said in the slides previously, that despite the actual VTP allowing you to propagate your VLANs, what it doesn't do is set the VLANs against the interfaces. So it doesn't do us our access ports or anything like that. So let's go back and change the VTP domain name to get rid of this error message. And if we look at the VLAN database, we can see that these VLANs have been created for us, but the VLANs are not assigned to any ports. And assigning them to ports will not propagate that port configuration out. All it's doing is ensuring that that VLAN exists on every switch in the network. And the reason that's important is because if we have a network that looks like this, let's say at the back of this switch here, we have another switch. Over here, we have a PC in VLAN 10, and we have off the back of this switch, a PC in VLAN 10. Then this guy in the middle here, through the power of VTP, will be aware that VLAN 10 exists, and therefore when traffic comes in and it's broadcasted or unicast switched out of the ports, end-to-end communication is successful. If VTP did not exist and that VLAN head did not exist on this actual switch, then what would happen is as traffic came in and it hit this switch here, then the traffic will be dropped because VLAN 10 does not exist. And if VLAN 10 does not exist, then there's no MAC address table, no spanning tree instance, no nothing. So VTP is an attempt to ensure that that layer 2 path between two clients inside the layer 2 domain is successful end to end. So that's all we've got time for in this video. Just to review what we've done. First of all, we jumped onto the CLI and had a little play with VTP and confirmed what we knew about VTP in regards of the different modes and how it actually works and propagates. We made a few mistakes where I didn't configure the link as trunk ports, and now we know that trunks are required to send those VTP messages. And we also know that this version of Packet Tracer updated the VTP domain name as I would expect in a real world production. So that's always great. So we've had a little good play there, and it's really important that you also go off, open up Packet Tracer and have a play yourself. So when you come across those problems like I did, it forces you to go troubleshoot. And if you spend 20 minutes trying to get something working, there's a good chance you're going to remember it versus reading it for 1 hour. So go and have a look at VTP and have a play of it in Packet Tracer. The one thing we didn't talk about was V2b Pruning. So let's have a quick chat about that. V2b pruning is a method to help reduce broadcast, unknown unicast, and multicast traffic across a layer 2 domain. So what do I mean by that? If you have multiple switches set up in your network, let's say for example we have a network set up like this, and across this network we have multiple clients plugged in, all off, and these circles are clients. And let's say for example that there is a bunch of VLANs configured, for example VLAN 10, VLAN 20 and VLAN 30. Well, normally in VTP, and with all these in the VTP domain name and trunk ports between them, then those VLANs, VLAN 10, 20 and 30, are propagated out and everyone knows about them. And it also means that if there is broadcast traffic for VLAN 10, let's say for example an ARP request, then all of that traffic will go out of all the ports, and in turn every switch will receive that broadcast traffic. Now, V2b pruning is an attempt to kind of prevent that unwanted broadcast traffic. And the way it does that is, let's say for example down here on this switch we have those 3 clients, and those 3 clients are only in VLAN 20. So this switch has no need to receive VLAN 10 and VLAN 30 traffic. What happens is V2b pruning sends messages to the upstream switches advising not to send VLAN 10 and 30, and in turn what that means is the upstream switches will no longer send that traffic on that port down to those switches, therefore reducing the actual traffic required throughout the network, as in the unwanted traffic. If at a later date you decided to have a client and put that client in VLAN 30, then this will send another message advising that it's now okay to send VLAN 30, and therefore we should only not be sending VLAN 10. So pruning is a method to ultimately allow the switches to communicate with one another, and based on the access ports and what VLANs are being configured, ensure that only traffic for those VLANs are sent to each other. Now, V2b pruning has to be enabled on all switches have to support it, and it's configured throughout your entire domain. The actual joining and removing of VLANs and so forth is done automatically, so all you have to do is type one command on all of your switches and they all participate in V2b pruning and able to optimize themselves for V2b pruning. So something that you should go off and have a look at Packet Tracer, have a play and see how V2b pruning actually works. I hope this video has been informative, and I'd like to thank you for viewing, and if it has been, please do like and subscribe.